basically we will talk about creating a custom harness. We'll talk how to replace the default harness, and in the second part of the talk we will also look at a crate we were creating and thought to speed up the test discovery and registration, and we'll basically go over the motivation and then examine the default tools and introduce some key building blocks, and we'll also explore how our own crate works, and then we'll also go into how to run Rust tests from CMake with CTest, and hopefully we'll have some time at the end for questions. So the main question is, why would you like to replace the default harness? The default harness is great for Rust-only projects, but basically falls short as soon as you start mixing languages or build systems. And the custom harness basically enables, a custom harness would enable you to integrate your Rust tests with a different build system, for example, or if you need some custom CI reporting, it would also be very helpful. Or maybe you would also like to have more control over the life cycle of your test cases. And so if you want to, for example, initialize a database or spin up a container or something like that. So that's where a custom harness would be very useful. And basically, so it's just a few reasons why you would need a custom harness, and I will move on and look into how the default test pipeline looks like. And here, for example, just a minute. For example, so if we run cargo test, the Rust compiler will be invoked with --test, and this means so the Rust compiler will generate a few things for us, basically generate a main, and also some for each test case where it will generate some metadata, and would obviously also link libtest, the default test runner, and then at runtime libtest also will basically print our test results, pass arguments, and a lot of other things. So, but as soon as you need to override the main function here, you will lose this automatic test discovery. And let's see why this is going to happen. So this is a very minimal example, and then we basically, if you expand the test macro, this is what it's going to look like. And so basically, we will have here, this part is like this test metadata I was talking about, and then here it's generated a main function which it's going to call into libtest main. And this is why this automatic test discovery is working. And so basically, the default pipeline is very powerful, but as soon as you need to override the main function, you will lose this automatic test discovery. And next, we'll look into what is going to happen if we opt out the default test harness. And basically, the Rust compiler will be invoked without the --test flag, and you will need to provide your own main. So you will need to write your own main, and in your main, basically you have different options. So you will need to think about how to discover your test cases and also how to run your test cases. And yeah, for running your test cases, you can implement a test runner from scratch if you feel very comfortable and you know what you are doing, but then there are also a bunch of, so I would not recommend that. There are a bunch of community crates which can provide a runner API, and here are just a few of them, a few of these crates. So these crates all provide you with a custom runner, but they will not handle the test discovery for you. And if we look now into an example how to use libtest-mimic, so libtest-mimic basically will, so here is your own main function, and then basically you need to manually register each test case in here and then call into libtest-mimic. And especially this part is very annoying. So this part is very annoying, and to help with that, so there is another crate that could help with that. And so linkme, basically linkme, what it does, so you could register test functions at compile time, and you just need to annotate your test functions, and then they all will be gathered in a list. And basically it helps us getting rid of this annoying step here. And basically, so if I sum up this section is, so this community crates here help with test execution, but you will need to take care of the test discovery yourself. And especially this test discovery part is where what we are looking into with our crate. And next, so I will hand over to my co-speaker who will walk you through how we solve this problem in Satchel.
All right. So as we've seen, there's a lot of power that comes with kind of building your own test harness, but also a lot of responsibility. You basically have to do everything from scratch, and not everything is currently covered by the Rust ecosystem. So because I actually ran into this problem for the last customer I was working for, we actually started writing our own crate called Satchel that takes care of this test discovery, which is sort of the last missing piece that you need if you really just want to recreate the normal cargo test setup, but for some reason you can't use just the default lib test. I'll go a little bit over also one of the use cases for that, but let's first see how, when you're using Satchel, test discovery works and how you can then drive your test runner. And the thing that Satchel gives you back, which we were still missing up to this point, are the test and the bench macro. So this is something that we're all used to, right? We've probably, all of us have written hundreds, if not thousands of functions annotated with tests. And at least I haven't really thought about too much how that even works and how important that little macro is. But if you don't have it, you quite quickly miss it. So we went out to recreate it, and it's actually quite simple macro that is implemented as a procedural macro, and basically generates these distributed slices that linkme provides us with. And linkme will then statically, with basically zero runtime cost, collect all of these items at link time, no matter where they are in your crate. And in your main function, you then have an easy way to finally find where all of your tests are, and you don't have to manually specify them out. Many of us know this from CMake, having to write out each file where you find tests or code or anything gets annoying quite quickly. So with this, we don't have to do it. And because it's generic and not tied to one specific runner, we can use whatever means of running our tests that we want. I also hope that something like this will encourage a bit more experimentation in the Rust test runner ecosystem, because there's still many things that we could experiment with as a community, and that maybe you also already need in your products that the default cargo test runner doesn't provide you with. And currently the barrier of entry is quite high. You always need to modify the default test runner or use something like libtest-mimic, which doesn't have automatic test discovery. But with Satchel, you can now try experimenting with whatever test runner you want. So using that crate is almost as simple as it should be, which is just slap test or bench onto a function, and that's pretty much it. Just don't forget to also import these macros from Satchel, because before you got them for free. Sorry, we can't do that for you in the ecosystem yet. So it's 90% there. So if you then want to write your own entry point, you can just use this Satchel get tests macro and then do whatever you want with the data that falls out of it. It will tell you what your test's name is, what function it needs to call, and then you can pass it to whatever runner you have. So in this case, this is a wrapper around libtest-mimic, but it doesn't really matter, right? You can use your own test runner. You have all that power again, but without all of that annoyance. And one very important use case that this does cover, and that we can see here it being used, is compatibility with existing C and C++ build systems. So if you just have an existing build in C and C++, there's often years and years of experience that have already gone into just building the damn thing, right? There's so many projects that just take an hour to compile. And there's a good reason for that. It's just complicated, complex software that we need to be building. And you don't want to just say, okay, I'm going to throw all of that away because I'm adding one Rust module and I want to test it, right? You want to reuse this stuff. So that means you're going to want to rely and keep using the old build system as long as it is useful. And for that, in many cases, you can't have cargo drive the linker. There's just so much complexity in one linker invocation with a complex project that you don't want to have to recreate all of this in cargo. So in many cases, you will want to use CMake as the final linker, and you don't have access to libtest. Or, as was the case for our recent customer project, your C++ code will have to do a bunch of setup. There is some kind of framework involved in C++, be it spinning up a Qt application, connecting to some databases, that sort of thing, which in this case needed to happen in C++, and there was a lot of code generation involved on the C++ side of things that we couldn't easily pull in from Rust. And so just having the ability to flip it onto its head and call the cargo test runner or something akin to it from C++ was really, really valuable. And with this, it is as easy as just putting extern C on your main function and exporting it to whatever downstream system you need. Those of you who've been at the workshop yesterday already know, then if you have a library that you're building with cargo, putting it into CMake nowadays is luckily not that hard. There's a project called Corrosion, which can do that part. So with that, you can import a crate into CMake. So we're looking at CMake code here. And there are similar projects for other build systems for whatever language you may need. And now that we have everything in CMake, we can now also use the normal CMake testing ecosystem. So we can register Rust tests as C tests. That is quite useful if you already have an existing infrastructure around all of this. And you want to keep as much of this as possible. And now we can, with a system that still ends up looking quite a lot like the default cargo testing workflow. So then here we're also seeing that we're pulling in another C++ file. This can, of course, be arbitrarily complex. But from that side, pulling in our test runner is just as easy as forward declaring a line of code and then calling it in our main function. And we now can run our tests with as much C++ setup as we may need. And in the case of our previous customer, this was quite a lot. It was quite involved to just spin up a bit of code to be able to run our tests. And it was just super, super valuable to be able to use the Rust ecosystem to recreate still that amazing testing experience while being deeply embedded in a C and C++ project. And that's also sort of the key takeaways from this is sometimes you just need to do something custom, right? And maybe it's not because you want to go far away from what the sort of standard solution is, but maybe there's just a reason you can't quite make it work. And for test harnesses especially, this is something that gives you a lot of power, and that I also would like to experiment just a little bit more with, just using a bit more interesting testing approaches potentially. But with the Rust ecosystem, we have this amazing, super easy to use testing workflow. And that is very valuable. So whatever you do, keep that simplicity and that ease of use, and do your best to, whatever you're doing, also keep those big advantages that you get from the default system. And from what we have found, the Rust ecosystem is quite far in that regard now, because we have things like libtest-mimic, which do a great job of just imitating the default test runner, so keeping compatibility in that regard, that make it practical to build your own test harnesses in whatever environment you're in. And we've just added a small little helper for that whole aspect as well, called Satchel. Of course, it's a free and open source project, liberally licensed, so check it out. It's on Crates.io. And with that approach, it is quite straightforward to integrate your testing system with whatever existing infrastructure you have, for example, be it CMake or CTest. And I hope that's just a little bit of help for you and in your next project. Thank you.
Thank you, Manfred and Leon. So we already have a few hands up here, so I'll go left to right, but I see you over there too.
Very nice talk, thank you. Have you been following the latest work on the libtest rework, and how does that affect, if at any, the future of something like Satchel?
I have not followed that too closely. I know it's been also moved out of the, or it's moved repositories recently. I don't think it is currently available unless you use rustc with the test flag. If that is not quite correct anymore,
I don't think they're there yet, no.
Yeah, and I also don't know if they have a plan to do especially test discovery outside of compiler-supported ways. They do?
They do.
That's great to hear. So hopefully that will then at some point become a standard feature, which is also part of the reason why we like to just keep the syntax the exact same by implementing Satchel, because then it's a question of just get rid of the use statement and you're back to using the default libtest, the default libtest approach again. So hopefully that'll, in a few years' time, be a whole standard solution.
Okay, there's another one here. Yeah.
Thank you. How big of a hack is linkme? Would you recommend using a similar thing for collecting web routes in Exum, for example, or something?
So it does rely on linker sections, which if you've used, for example, dformat, that is also something that you might be quite familiar with. If you are still using, for example, Cargo as the main compiler, it's actually not bad. Like linkme works pretty well on all the major platforms. There can be some issues if you're exporting your whatever you've built as a static library into another ecosystem. I'm hoping that we can also get a better compiler support for that specific use case, but that's another story. So there are pitfalls. We have documented them for Satchel specifically because it does rely on linkme. But if you're in the Rust ecosystem, I actually have had good experience with it, and I would keep using it. Yeah.
Okay, and then over here.
Thank you. What do you do differently from, for example, Cargo next test, which allows them to reuse the test macro, but not you?
So for that, I think it's good to actually go back to one of the early slides, because Cargo next test doesn't actually use a custom test harness. So if we look at it here in that scenario, Cargo next test basically just replaces this part of the whole chain, but as soon as you get to compiling the actual test binary again, you just reuse the default test harness. So cargo next test uses the normal test harness, but it just calls your binaries differently. So cargo test will just call your binary once, and your binary will run all the tests. Cargo next test calls your binary multiple times and executes each test individually, collects them differently, which allows you to parallelize differently. So yeah, that's a good thing to mention. That is sort of the sort of last step in that chain, which you can already currently replace, is the runner that actually discovers the binaries themselves and invokes the binaries, which, for example, we have in the example replaced with CTest, for example. So in that scenario, basically cargo next test would be on the level of CTest, and CTest doesn't really know what happens inside your binary. So that's yet another layer of testing.
Okay, and over here.
I'm having two questions. Firstly, what is actually the motivation for running the Rust tests from CMake in your case? Like, yeah, well, what's the motivation there? And then secondly, actually some things like Satchel could be really useful for deformat because we have some limitations there around how we run tests. But it's currently not nested. Is there some fundamental limitation in there, or is it just a question of annotating it?
Yeah, I think we might just need to annotate it with a no-stud feature. So yeah, we do use strings, but maybe I think they're just static string slices. So we can probably fix that. Yeah, so first question was, sorry, motivation, right. So in our case, it was really mostly the case of there was a giant CMake code base, basically, next to the C++ code base. And that means all of the information of how do I actually get to a binary with all the dependencies that I need is in CMake. It's not in Cargo. So I didn't want to use Cargo to run the linker. I had already imported everything with corrosion into CMake, and I had it all working, right? So I could add Rust code to my existing CMake build, but not the other way around. And that's what you need for Cargo test to currently compile in libtest. So you don't get access to libtest at all if Cargo is not driving the build at the moment. And so we're hoping that will change, but because that it's just not there yet, that was the only option. I somehow had to do testing from CMake, but I really wanted to have that great experience of just slapping test on a function and being able to run it. And so I Googled a little bit and found out that we're not quite there yet, but now we're pretty much there. So I just had to put together the remaining pieces, and it's been working really well.
Any other questions for Leon and Manfred? Here, Till, and one over there. So I'm going to go to Till first, and then we'll go back. I see you, Till.
Do you see any issues with sort of combining the output of the two? So is it all serialized, or if you start doing things in parallel, is there a mess with like standard out and stuff? Or like how do you collect the returns from the test? Is that all? I'm just imagining that might be a mess, but it's not.
Yeah, so in that case, this is actually a problem for libtest-mimic, which by default, I think, runs tests in, I'm just trying to remember. Huh?
In human writable format, so it's outputted.
Yeah, so the output is in human writable format, and it's very similar to what Cargo test does, but libtest-mimic does not actually capture the standard output like Cargo test does. Again, because of reasons where the Rust libtest can do more because it's embedded into the Rust standard system. At the moment, you basically just don't have output from your test because it's just, you usually would want to just suppress it and enable it only if you see a test, for example, fail and you want to debug why. That's the approach I've gone with for that particular customer. By default, we're suppressing all logging, and only if you pass it a flag, you re-enable it again, because in 90% of cases, you just want to see test pass, and then only if it ever fails, you enable logging again, run that particular test again, and then you know what went wrong, basically. And in the other case, I could also recommend just logging everything to a file, then you can still introspect it if that is if you have a test that you can't reproduce.
Okay, we have one last question back here.
It said that it turned off, but one of the part of a test harness is KFG test, which is technically a feature. You can feature guard the code with CFG test, but there is a famous problem that you cannot pass the this feature guard to other crates. Do you do this somehow differently? Because currently you're basically faced to introduce a testing feature that you and feature guard with any test and testing.
So yeah, you're right. We can't really do config test that easily, especially if you're using corrosion for other reasons that I don't really want to get into. But so we literally have on that crate a testing feature that you just enable in debug builds with testing, and that compiles it in. So that's actually true that if we look at the very default example, I don't know if we can get the slides back.
Can we get the slides back, Stephen? Thank you.
Yeah, perfect. So in our case, instead of config test, it is actually config feature equals test. So slightly different, but feels pretty much the same.
Okay, thank you, Manfred and Leon, for your talk and for your insights. So, thank you.